Today I'm gonna be solving the 3.1 chemistry quiz. If you ever get a question like this, just know that the concentration is the same for everything. So KOH splits into K plus OH minus. Concentration is all the same because they're all 1-to-1 ratio. Concentration is just moles over volume, it's all the same volume, all the same moles. So if this one's 0.06, so is this one, so is this one. So since they're all the same, that means that OH is also 0.06. KW equals to H plus times OH minus. So that means H plus, what they're asking for in this question, equals to KW over OH minus. And always, like at least in the quiz, KW is given to you. So it's 10 to the negative 14 divided by 0.06. So the answer is 1.7 times 10 to the negative 13. Always look at what they're asking, like the scientific notation, how many significant figures. Times 10 to the negative 13. Substance that dissolves partially, it partially disassociates. So it's a weak electrolyte, and these two are strong electrolytes. You have to memorize which ones are weak and which ones are strong. The easiest way you can tell is if, when you memorize the equation, or when you just see the equation anyways, if it has one arrow, it's strong, because it doesn't go back, it fully disassociates. But for example, acetic acid or ethanoic acid, CH3COOH, it disassociates into CH3. It's reversible. If it's reversible, it's weak. COO minus plus H plus. See, if it's reversible, it's weak. If it's one arrow, it's strong. It's always how it is. Is a strong electrolyte. It's a strong base and a strong electrolyte. See, you can tell here, it's only one arrow. So you have to tell everything. They give you here that calculate. This is a different part. It's unrelated to the first one. But look here, see? Here they tell you calculate concentration in the 0.03 solution of NaOH. So NaOH gives you Na plus OH minus. Again, it's 1-to-1 ratio. So concentration here is a concentration here. So that means if in the NaOH is 0.3 and the OH minus is 0.3, and they already give you KW again like the last time. So you already have OH, just put in the question. So it's 3.0 times 10 to the power of negative 2. And then H plus, you have to find it. So then it's like this, KW over OH minus gives you the concentration of H plus. So 10 to the negative 14 over 0.03 gives you 3.3 times 10 to the negative 13. Let me double check. Yeah, 3.3 times 10 to the negative 13. Here you have to use stoichiometry and the formulas from last year. So here they give you the mass and they give you the volume. You have to find the concentration. Concentration, C equals N over V. You have V, but you don't have N. If you remember from last year, N equals to mass over molar mass. Here the molar mass is given. It's 172. And this is the mass. So that means N equals to 2.5 divided by 172. And then whatever answer you get, I'm gonna keep it as a fraction because the decimal is really long. It's 25 over 1720. And then you just divide that by 0.1 because for volume it's always in decimeters cubed or liters. If it's in centimeters cubed, you have to make it decimeters cubed, and if it's in milliliters, you have to make it liters. It's just divided by 1,000. So if you do that, do 2.5 over 172, you get your answer, and then you divide it by 0.1. The answer is, it said two significant figures, answer is 0.15. Here it's not the same like last time because it's not 1-to-1 ratio. When you do it, OH2 gives you Ba plus 2 OH minus. It's not 1-to-1 ratio this time, it's a 2-to-1. So 1 to 2. So that means this is 0.15. You have to cross multiply. So if 1 BaOH2 and 2 OH minus. So if 1 gives you 2, 0.15 gives you X. Cross multiply, it's 0.3. 0.3 is, in scientific notation, 3.0 times 10 to the power of negative 1. And then here kW is given. They might not give it in the exam, you have to memorize it. It's 10 to the negative 14 at 25 degrees Celsius. Okay, so it's 10 to the negative 14 divided by concentration of OH, so 0.3. The answer is 3.3 times 10 to the negative 14. A way you can tell if you did the equation and the volumes and the things correct is here the original compound had OH, so OH should be the bigger number and H plus should be the smaller number. Okay, you have the moles and you have the volume. So again, C equals N over V. Instantly, you don't have to get the N. It's already given to you. So it's 0.0075 divided by 0.25. You get 0.03. That's your answer. So of H2SO4, 3.0 times 10 to the power of negative 2. And then again, it's the exact same like the last question. If you write the equation down, H2SO4 gives you 2H plus SO4 2 minus. It's a 1-to-2 ratio. So if 1 H2SO4 gives you 2H plus, then then 0.3 or 3.0 times 10 to the negative 2 give you x. Cross multiply, answer 6.0 times 10 to the negative 2. Then you do kW over so 10 to the negative 14 over this, and you get the answer. So you do 10 to the negative 14 over 0.06. (1.7 times 10 to the negative 13). This one, again, it's a 1-to-1 ratio, so NaOH gives you Na plus OH minus 1-to-1. So whatever this is, they already give it to us, 0.05. And then scientific notation, 5.0 times 10 to the power of negative 2. And then exact same thing, you do 10 to the negative 14 divided by 0.05. You get 2 times 10 to the power of negative 13. 2.0 times 10 to the power of negative 13. So here again you have to use the N equals M over M and C equals N over V. So M is 0.8. Always in an exam, write it down. It's gonna make everything easier, right? Whatever formula you're gonna use. And then here you have to add them up to get the molar mass. So capital M equals 23 plus 16 plus 1, which just equals 40. Yeah. So you do 0.8 divided by 40. You get, so after you get N is 0.02, and then N over V is it's given here, so 0.1 liters. Never forget the, in written part, never forget the units. So then you just do 0.02 over 0.1. You just get 0.2. So the concentration is 0.2, 2.0 times 10 to the power of negative 1. And then you do 10 to the negative 14 divided by 0.2. Five times 10 to the negative 14. An electrolyte. You have to remember this is called an electrolyte because it conducts electricity. Because it has charges because of the ions. Substances like, you have to remember, strong electrolytes who strongly conduct electricity. Ethanoic and acetic are the same thing, they're just trying to confuse you. Weak electrolytes because it's not that good at conducting electricity. Kw is, see, at 25 degrees Celsius, 10 to the negative 14. And if you do the math, if they're equal to each other, and if you times them, you get this. So it's 1.0 times 10 to the negative 7. Each of them. So look here. The reaction is endothermic. So that means the heat is going this way. It's getting absorbed when you go this way. So when the temperature increases, you're trying to decrease it. So how do you decrease it? You're gonna absorb it. So you're gonna go this way. So that means this will decrease and this will increase. So if this increases, then obviously this would increase. That's why when you increase the temperature, it increases. So it will absorb, the value of Kw will increase. OH minus and H plus because it's water. That's how you get water. There's two H's and one O. If we add any OH to pure water, OH minus would be greater than H plus, obviously. And then Kw is concentration of H plus times the concentration of OH minus. That's it.